Hello and welcome, Babylonians, to this technical introduction workshop for the Babylon Hackathon. My name is Bruno, and I'm a technical educator at the Web3 Foundation. And this foundation is the one that's spearheading the Polkadot and Kusama projects, and also some other things, as you'll learn. In this introduction, I would like to talk to you about a fun project that I'm currently working on, and hopefully use that project to inspire you to kind of become creative hackers in your own right, because this project in particular uses some fairly unexpected logic to bring non-fungible tokens to the Kusama blockchain, which by itself doesn't have any smart contract logic, which means you can't really do any advanced computation on the chain itself. Now, to unpack what all of this means, we will have to start at the beginning, and we'll go through all of these terms so that you finally, at the end, understand why I've done what I've done and why I'm building this tool set. And hopefully, this will inspire you to play with substrate-based chains in a similar manner. And I'll explain what substrate-based means as well. So, let's get started and explain and start at the very beginning. So, first, what's an NFT? Well, every blockchain has its cryptocurrency, and that we can call cryptocurrency a token, right? So even Bitcoin is a token on the Bitcoin blockchain, Ether is a token on the Ethereum blockchain, but also Ethereum supports a lot of other tokens that are built using smart contracts. And every blockchain has its own version of tokens, both native and smart contract derived. But in essence, a token is just a currency represented on a blockchain in a specific way. By definition, these tokens are fungible, which means that if you send one Bitcoin from one person to another, that Bitcoin is not actually, those Bitcoins are interchangeable, right? One Bitcoin that I get from Alice is interchangeable with one that I get from Bob. Of course, there is this transaction monitoring and checking if the Bitcoin came from a stolen stash from an exchange or something like that. And this kind of reduces the fungibility, the interchangeability of these tokens. But in essence, one Bitcoin will always be equal to one Bitcoin. And this is the domain of fungible tokens. And before we move on into non-fungible tokens, it's worth pointing out that when we're talking about tokens on a blockchain, it's very simple. It's much easier to think about them if you visualize it as one big Excel sheet. And that one big Excel sheet has a column that has the list of users, and then there's another column that has a list of balances. And all the miners in a blockchain are just constantly keeping an eye on that one Excel sheet. And you, as a user, have the ability, the permission to only change the value of your own cell, and you can only change it downwards. You can only change it by subtracting from it. And however much you subtract from it, you can add to somebody else's column, or somebody else's cell. And if you do that, somebody else's balance will increase and yours will decrease. Now, what's preventing somebody from doing that willy-nilly to anybody whenever they want? Well, exactly those miners who are looking at the spreadsheet at all times. So everybody is checking that the changes that everybody is making in the sheet are valid. And whoever makes an invalid change just gets kicked off the network. They lose permission to edit the spreadsheet, right? So this is how you can visualize token balances on a blockchain. Now, in non-fungible tokens, you have the exact same thing, but the entries are much richer in data. So, for example, if we have something like a token that represents a samurai, and those samurai are collectible illustrations of samurai. And now, one samurai is green, the other is red, another is blue, and so on. But these entries in the spreadsheet will have multiple values. They will have these descriptors, like which color they are, what skills they have, but they will also have their owner. So just like with the balances on the fungible tokens, they have this balance has this owner, this balance has this owner. The non-fungible tokens also have their owner. And the way you trade them is you just change the owner, right? You just edit the owner field, and then suddenly you've moved that NFT, that token, that non-fungible token, to somebody else. So what makes it non-fungible? Well, every samurai is unique, right? Every samurai has its own serial number, as in when it was created, and is unique in some attributes. Now, there may be two blue samurais, but one of those will have been created before the other, and their serial numbers differ. So, in effect, they are unique. And this is what makes them non-fungible. One samurai does not have to be equal in value or utility to another samurai, right? And non-fungible tokens are actually collectibles on the blockchain, kind of collectibles, art, concert tickets, certificates. There are many uses for non-fungible tokens. And one of the most popular uses right now is art. So artists will tokenize their work, and then when you buy the digital version of that artifact online on a blockchain, the token gets transferred to you. Now, what's the point of that? If anybody can just, copy and paste the image, right? Well, the point is, for one, the reproduction rights. So you can sell the copyright to somebody else. Two, you can have royalties, so that you will get a percentage of every future sale of this artwork. And also, there's no real point in owning a physical painting either, right? There's no utility to it. It's a collectible. And maybe it has some value attached and you can sell it later. But it's the exact same story with digital collectibles. So with an NFT-based artwork, you can not only have it and speculate with it, but it can actually have utility in other applications, contracts, and so on. For example, imagine a video game which will have a unique sword, and then you have that sword in your crypto wallet. Now you can apply it to your character in a game, but you can also apply it to another character in another game if that game connects to the blockchain on which your sword resides, right? So you basically have usable items that you can transfer from game world to game world. And now we've expanded the use of NFTs. Another use case is if you have a art piece in NFT format. Imagine virtual worlds with virtual galleries in VR, and then you can just put your NFT into that virtual gallery in that VR world, like the Decentraland or a similar project. And so now we've actually gone into this kind of human computer hybrid world where people actually have these alternative living spaces which they can decorate with the collectibles that they've bought on chain. And because these collectibles are unique, non-fungible, and basically bound to their account, there's no way somebody else can easily steal them. If this were a game which resides on somebody's server, that person who owns the server could edit the information in there and display the same items you have, right? But since this is all blockchain powered, the system has no choice but to respect the rules of every account. So if I have a painting, somebody else cannot have that painting, unless the painting has been developed in such a way that multiple copies can exist. Those are then fungible, non-fungible tokens, and it's a whole other can of worms. But these are just some of the uses of non-fungible tokens. Others are certificates, diplomas, concert tickets. There's a whole bunch of applications for non-fungible tokens that that really benefit from this permanence on the chain and from this ability to take them with you in your crypto wallet. So, okay, non-fungible tokens are valuable, and they're all the rage on Ethereum. But what if we have a different chain that doesn't have NFTs yet, and that doesn't even have smart contracts? How do we bring NFTs over to that chain? Such is the case with the Kusama network. And the Kusama network is the... okay, let me rewind a little bit. So Web3 Foundation is building Polkadot and Kusama. And Polkadot and Kusama are both substrate-based chains. Now, Substrate is a framework for building blockchains, and you might get exposed to it through this blockchain hackathon because it's a very, very easy and efficient way to get started with your own custom blockchain, application-specific blockchain. This framework gives you a nice foundation for your blockchain. In fact, if you just clone it and run it, you already have a blockchain. And then you can just add in plug-and-play functionality to it that already exists in plugins called palettes. And these palettes you just pull in, add as dependencies into your node, and your node, your blockchain node, will get upgraded with that extra functionality. So you can customize your blockchain. But you can also develop your own palettes for truly custom scenarios for your blockchain. And that's where the power of Substrate shines. So Substrate is this foundation on which dozens of blockchains are already being built. But Kusama and Polkadot are two that are live. And now, Polkadot is actually this blockchain that's intended to be the communication hub for all other blockchains. Polkadot is kind of like this chain of chains through which other blockchains will pass messages. So if I connect Ethereum to Polkadot and Bitcoin to Polkadot, I can very easily and in a safe and decentralized way send Bitcoin onto Ethereum so that I can actually use Bitcoin for something, right? Bitcoin is useless as it is. It doesn't have any functionality, any smart contract functionality. It's very expensive. It's very slow. It's basically just gas that pays for itself. But if you move it to Ethereum, you can use it in DeFi. You can use it to get loans. You can use it for all sorts of things on the Ethereum space, which are not possible on the Bitcoin blockchain. And right now, you have some means of doing that transfer, but these means are all very isolated. So you have something like TBTC, which uses an incentivized group of nodes that will take custody of your Bitcoin and then mint a token on Ethereum. Or you have WBTC, which is wrapped BTC, where you rely on a centralized custodian to take your Bitcoin and mint a token. And these are all very separate solutions. It feels kind of disjointed, and you get two different tokens. But if you connect them through Polkadot, you not only allow Bitcoin to go through Ethereum through Polkadot, you allow Bitcoin to go anywhere through Polkadot to any chain which also connects to Polkadot. And that's the big seller there. Because you can also pass messages from the Ethereum connection on Polkadot to any other chain. So you're basically joining this information superhighway where all the chains can communicate with each other and all the chains are application specific. All right. So Bitcoin is this digital gold. Ethereum is this general world computer. There will be DeFi chains, NFT chains, gaming chains, and so on. And so you can move assets around from chain to chain. And these connected chains are called parachains. Now, this functionality is not yet enabled. And in fact, Polkadot as the stable conservative chain is slower to upgrade. It's playing things safe. And that's why it has Kusama. So Kusama is a canary version of Polkadot, which is more chaos prone, more edgier, friendly to experimentation. And it's not a testnet, it's like an experinet. It just wants to experiment with different features, different abilities before Polkadot inherits them. And maybe sometimes Polkadot doesn't get them at all. And so with Kusama, we get these edgy use cases that we can test, but Kusama also still doesn't have parachains. And it doesn't have smart contract logic. It's just this core chain that's waiting for other chains to connect to it. And while we wait for native solutions for NFTs to come to Kusama, because a lot of people are using Kusama already, I figured why not force Kusama to have NFTs? Why not put NFTs on Kusama regardless, despite there not being any logic to support them, so that people can get started making NFTs, and then when bespoke solutions come up, like a parachain specifically for NFTs that can talk through Kusama to other chains, why not use this solution that I can hack onto Kusama without breaking anything? And so this is where Remark comes into play. And before I go into Remark, I want to encourage you to really look at Kusama as your experimentation ground for this hackathon. So it's kusama.network, and it's a very chaos-friendly network where you can build a lot of different things, even though you wouldn't expect to be able to do so, because a lot of the functionality isn't there yet, but you can still hack around it, as you'll see very soon. So what is remark? Well, every substrate-based chain, and that includes Polkadot and Kusama, has a set of palettes or modules that perform some operations, that let you execute some functions. And you call the functions in that chain by issuing extrinsics. So what's an extrinsic? An extrinsic is an input from outside the chain into the chain, which causes an action. Now, it's like a command that you execute and that has an effect on the chain itself. So when you send a balance to someone on a substrate-based chain, you will send the extrinsic that says balances transfer. And the balances transfer extrinsic takes two parameters. It takes the recipient and the amount. And when that's sent to the chain and signed, the chain will look at that extrinsic and will apply its effect to the state. So the balance of the recipient will change if the extrinsic is valid, or the extrinsic will fail and you will still be charged the transaction fee because you still spent the chain's resources in order to attempt this and to emit an error event. So extrinsics are like these commands that you issue to the chain. The chain will charge you for them whether or not they're successful. And the output is either an error if you sent an invalid extrinsic, or a change in the chain state if it was valid. In fact, the state will change regardless because even errors are logged in a way. So what does this have to do with anything? Well, there is a special extrinsic called the system remark extrinsic. That means that it resides in the system module, the system palette, which is the core palette of every substrate chain. And remark is the function on that palette. So it's like a class and then a method on that class. And now, the system remark extrinsic is basically a blockchain graffiti. Whatever you send into a remark gets emitted into the chain. It isn't stored on chain in any state, but it's, I don't know how to put it other than screamed into the ether of the chain. It's literally graffiti on blocks. So by sending a system remark, you basically send any bunch of data into the chain, and every node will be aware of that data that you sent. That data will not have an effect on the chain state. It's not going to save anywhere, but it will forever be visible as an artifact on the block in which you sent it. So if you inspect that block where you sent that extrinsic, it will forever be there. Your action will be logged in as an input to the block forever. And by doing this, you can actually send arbitrary messages into the chain, which others can then read. So you can send these messages onto the chain, and they will be propagated to all other nodes that are connected to the chain. And then you can use tools like the Polkadot JS API to connect to the blockchain node and read those extrinsics back out. Now, this is much, much slower than just reading the chain's current state. So it's not practical for high volume applications or anything advanced, but it's very handy to hack something onto the chain which shouldn't be there. And that's what I did with Remark. So RMRK.app is, and you can visit this website by going to RMRK.app. RMRK.app is a way to get non-fungible tokens onto Kusama. And so how do we do this? Well, we have some standards. And if you go to the top of the page, I recommend you scroll through this entire website and read the examples and explanations. But what it comes down to is, in order to get an NFT, you have to define its structure so that other applications reading about that NFT know what to expect. If they come across a bunch of data, they have to know if it's, I don't know, an image of a turtle or a JSON file that describes what an NFT is. And so I wrote some specifications that document how an NFT and its parent collection need to look in terms of data. And so every NFT is part of a collection, and you define a collection by setting a JSON blob, which will say how many, let me increase the font a little bit, by saying how many tokens this collection can contain, what the symbol of the collection is, who the issuer of the collection is, what the ID is, what the name of the collection is, and the link to some metadata. The metadata is another JSON element hosted on IPFS, and it can contain arbitrary amounts of data. This is external because it is very expensive to save such values on chain, right? The more bytes you send, the more you have to pay. So it's cheaper to just include a link, and in this case it's a link to IPFS, which means that this link cannot go down. And then once you have a collection, you can define an NFT inside of that collection, and the format for defining an NFT looks like this. You have a link to the collection it's a part of, you have the name of the NFT, you have whether or not it's transferable, you have the serial number of the NFT, and again you have some metadata, and this metadata can contain some other stuff. All of this is defined in the specifications. And so by defining these simple standards for NFTs and their collections, you can emit these in the form of a remark onto the chain, and then anybody who reads these remarks will be able to see who and when created some NFT collections and some NFTs. But just creating an NFT and a collection isn't really doing much, right? It's kind of pointless. Well, that's why we have some interactions defined as well. So interactions are interactions between the outside world and NFTs and NFTs and NFTs. For example, you have here the mint interaction, which will let you create a collection. But you also have the buy interaction, which lets you buy somebody's listed NFTs right from the chain. So in order to list it, let's check out the list one. In order to list it, you would get a specification. Let me increase the font here as well. In order to list an NFT, you would emit a remark that looks like this. So you can see here the standard for listing your NFT for sale is defined as remark and then colon colon. Then you have the list as the name of the interaction, again colon colon, version of the standard you're using, colon colon, and then you have the ID of the NFT that you're selling and the price. This is denoted in the smallest possible unit of the chain that you're using currently. You turn all of this into bytes and submit it as a hex value. So this is basically this. And as long as you submit this as a remark onto the chain, and the tools for the remark suite can read this remark and find it later, you will actually be able to visualize that somebody has listed an NFT for sale. And then if you try to buy this token, you can see here the standard for buying it. So the standard is defined as hash, as hex of bytes of remark, buy, version, and then the ID of the token you're buying, and the transfer of the tokens required by the price. So in this case, we use the utility batch extrinsic, and the utility batch extrinsic is a functionality that allows you to put different extrinsics together and then execute them at once. In this case, we are going to batch together the remark that says I'm buying and the transfer of their list price. And so you get this basically. You get this buy extrinsic, which converted into bytes, you get this. And then you also get a transfer. So this is something like what it looks like in JavaScript. You batch together two transactions. One is the remark of our buy interaction, and the second one is our balance transfer. And by using these two together and sending them, we have basically hacked on trading onto Kusama. Even though Kusama doesn't have native token transfers and it doesn't have smart contracts, we were able to force it to allow trading of NFTs. And now, to recognize this change of ownership, there's another problem. How do we read these remarks? And this is especially problematic because as these interactions get piled up onto remarks in the chain, we have to keep track of the state as they pile on, and we have to recalculate the final state at every step of the way, because nothing is preventing anyone from issuing this type of transaction, even though they're not allowed to. Maybe I'm selling my token for this much, and maybe somebody decides to remove this many zeros and submit this regardless. Will their transaction succeed? Yes. But it won't succeed in the eyes of Remark, because the specification clearly defines that the price has to be equal to or greater than the list price that we defined. And to list, we have to define the price like so. So we have the hex, bytes, remark list version of the spec we're using, that's 0.1, ID of the token, and price. So price has to match whatever we're sending. And this is why it's important to have standardization of tools so that these tools can all agree on the final outcome of all of these remarks when they find them and process them. This is the challenging part of Remark. So in practice, we have the following two repos you should check out if you want to get inspired and hack your own stuff onto this. The first one is the specs repo. And the specs repo will document the specification, the standard for entities and interaction. So entities are NFTs and collections. And interactions are mint NFT, consume, change issue, send, buy, and list. So these are all interactions that you can do with your NFT. In the relevant folders, you will see that, you will see in the standards folder, you will see that these are all documented. So if you go to interactions, you can see them all here. And here's the mint interaction. How do you mint a new token? You emit a hexacoded value of the remark that says remark, mint, and then the JSON of the collection you're minting. Once you emit this, your collection will have been created. So these blueprints, these standards, are what implementers should use when they're building their own tools for Remark. And while we're on the topic of tools, you have also here the tools repo. This is a very, very early alpha, and I've only submitted a couple of code changes here that are not exactly meant to go live in any way. I'm working on this actively right now, so please don't fret if it's broken or something. But anyway, this tools repo will be the first official implementation of the specification for Remark, so that these can be implemented into wallets and UIs and so on. And this will automatically sync to the latest state of all remarks on the target chain where you're adding NFTs, in my case on Kusama. And let me actually demonstrate some of this right now. So if we go to this chain, so this is my development chain. I'm running a local copy of Polkadot on my computer. And by copy, I mean I just cloned Polkadot and then I ran it in development mode, which means it ran from block 0, and it comes with some accounts that have money that have been pre-seeded for development. You see here Alice has a bunch of unit, Alice Stash has a bunch of unit, Bob, and so on. So these accounts have money that is for development. You can see here under Network Explorer, you'll notice that we're getting blocks, and we're at block 9,000. And so this, if you click on a block, you will see all the extrinsics that happened in that block. There you go. 2 extrinsics have been set. Timestamp is set in every block so that we know when a block was created. And here we have finality hint, which I won't get into right now. But essentially, excuse me, every block has a set of common extrinsics. Now, let's try and submit a remark. So if we go to developer extrinsics, you will end up on this screen. On this screen, you can select which account you're using to submit the extrinsic. We'll use Alice, which is the unlocked seeded account. And then we go to system module, remark function. And here you can submit anything you want. For example, 0x323444555. 6. So this is a hash. It's just some data, just some bytes that I've decided to put into the chain. And if I submit this, sign and submit. Okay, now we have submitted this, but we don't know. Let's try and find it in a block. So we have this chain info here. So we don't know when this happened. So let's try and check out some blocks. 2, 2, 2 here. All right, let's see. And now we will see this extrinsic happen in one of these blocks that we opened. I'm not sure in which one it happened. So this doesn't have that extrinsic. 9733, not here either. There we go. There it is. Okay. So it happened in 9734. And you can see the extrinsic is logged here. And if we expand this, you can see here that the remark was actually translated as 34DUV, because that's how it translated from the value that I entered. So this actually, when it's decoded into UTF-8, it ends up being 34DUV. So this is how remarks work. And now we would have to go back when we were looking for some values. We would have to go back and look for all the extrinsics, for all the remarks in past blocks, right? So we know this one happened in 9734. Let's try and find it. I'll show you some code right now from the remark tools repository, which reads these extrinsics. So this is some very rudimentary code for fetching these remarks. First, we will import some types that we need. This is TypeScript, so we need some types. And then we will import some utility functions. Notably, I have an API bootstrapper, which creates an API instance for me that connects to my blockchain. And I also wrote a utility function to get the latest block. I can show you these right now here. So here we go. I import the API from Polkadot API. And then I have one function that creates the API for me. It's just a simple provider, and then I create. This is all from the docs of the Polkadot JS API. And the getLatestBlock function uses the API RPC chain endpoint to get the header, and then it translates that header to a human readable number of the latest block of this chain. So why do we need this? Well, because I wrote a command which expects a from option, a to option, and a WebSocket option, along with a prefix option. So what do each of these do? The WebSocket option will tell the fetch remarks function to which WebSocket endpoint to connect to. It will default to my local network if not provided. So my local chain for testing. From will say from which block it should search. To will say until which block. If to is omitted, it will default to the latest, and that's why we need the getLatestBlock. And from will default to 0. So if you omit from and to, it will just search the entire blockchain for remarks. Not recommended, very, very slow. This is why it's useful when processing this to have checkpoints. So you would process like 1,000,000 blocks and then save that, and then process the next 1,000,000 and save that, and go through blocks that way. So you would have batches saved from before, and you don't have to reprocess them. And the prefix is whatever we want our remark to start with. If you remember, in our specs repo, we had every single interaction start with the remark prefix. So if you go here, and if you look at some of the interactions, You can see each of them starts with remark : colon. So this is a good prefix to target so that we can ignore all other remarks on the chain. Because a lot of people are submitting a lot of remarks for different reasons, right? We only want our remarks processed. And so this entire function will just process these arguments, and then it will just go through these blocks, get every block's hash, then find a block for each of these hashes, then grab the extrinsics from each of these blocks, and if they are part of the system remark extrinsic, it will extract the argument and then check if they start with the prefix, and if so, it will push them to an array, which we finally get back in the console. Let's see that in action. So we know that our extrinsic happened in block 9734. I have my tools here, and now we'll just run yarn fetch. This is because I defined the command in remark tools repository. You'll find it in package.json as a defined command. We'll say from block 9000. We'll omit the to flag because we want it to go from 9000 to the latest block. And we'll just see what that gets us. So now it's fetching. It tells us it connected to my local node, which is WebSocket 127.0.0.19944, which is the default port on which the node is running, and it's processing block range from 9000 to 9815, which is the current latest block. And you can see here that we got in block 9734 our remark 0x33344455556. So we got it. That's great. We can also search by prefix. So if I add in a prefix of, I don't know, 0x1234, then it is not going to actually find anything. Now, the reason this is taking so long is twofold. One, this is a non-compiled version which goes through the TypeScript interpreter first and then executes the JavaScript in the code. Two, it's because it's processing a lot of blocks over and over again every time we run it. Ideally, we would just save all the remarks we found and then just process the next range, but this is just for demo purposes. So we got back an empty array, which means it didn't find any remarks with this prefix. All right, let's try our prefix that we know exists. So let's see 0x333. And let's speed it up a little bit, put it to 9700. There you go. So now it found the remark that we've been looking for. So we can define a prefix we want found, and this is actually going to work even in UTF-8 mode. So because we saw that our remark is translated as 34 DUV, we could potentially put 34 as a prefix, 34D for example, and that should produce a working prefix. So let's see this 34D. Let's see if this works, because it's going to automatically translate it into hex. There we go, it found it. So prefix works both ways. You can put in, and this is just a demo of the code used to process these remarks from the chain, to get them out. Now this code just gets them out. What you do with them is up to you. So I hope this inspired you how to hack custom things onto a Substrate based chain, because they all support these remarks, and this is very interesting. And Polkadot JS API is actually fairly straightforward to use in this way, because it has all of these direct interactions and connections to the chain that you can use to query it for data, either from the node directly or from the block or from the state or whatever. So go to the Polkadot JS API docs, look into that, hack through it, try and think of a scenario that you could use with remarks, and let me know what you come up with. I am open to any questions. If you have any in the chat or via email, just contact me, bruno@web3.foundation. You can also find me on Twitter @bitfalls, BITFALLS. And also, let me just put some ideas in your head about what to use this for. So, since everybody sees the remarks, you can use it to create and this is what a developer from Parity, the development shop that builds the Substrate framework, did a year ago, to develop a collective drawing. So everybody can submit some coordinates and a color into the remark, and then a script would read all of those remarks and draw those on a canvas. So you get a collective drawing application. Whatever you submit as a remark gets drawn on the pixel, and this is how you can basically get like a 1,000,000 pixel website that people can color and paint and so on. Another implementation is a chat app. So you can basically use a prefix to define a chat room, and then everybody can emit remarks into that chat room and other people can see them. So all you need to do is build a script that will read the messages of a specific chat room and display them, and you have a chat room. You don't even need historical past blocks for that, because you can subscribe only to new blocks. So when somebody joins a room, they don't have to see the history of messages. They can just see the new messages since they came in, which is fairly interesting. So go out there, go wild, explore the network, abuse the network. It's what it's there for. Try to implement some of this crazy functionality, and I wish you luck. Let me know if you have any crazy ideas, if you need help with anything, or if anything is not clear. I'm always at your disposal, and I hope to see you in the Polkadot ecosystem. Thank you very much, and until next time.